Okay, so get ready to dive deep today. We're talking deep sea fish and how they use their senses in a place where, well, there's basically no light.
Yeah, it's pretty crazy down there. And we've got some fascinating research to dig into, like this new stuff from Yaroslav Kamala that looks at just how these fish are making it in such an extreme environment.
I mean, we know they have to rely on senses other than
Hmm.
sight, but I'm ready to have my mind blown by the specifics, like how much are we talking here, and what role does smell play in all of this?
You're definitely thinking in the right direction. Imagine a world with practically zero light. Your sense of smell would basically become your lifeline.
Totally. For finding food, avoiding becoming food, even finding a mate. It'd be like their whole world is scent.
Exactly. And that's what's so cool about Kafferman's research. They're really trying to understand the mechanisms behind all this at a genetic level, even.
Okay, so how'd they go about doing that? What was their approach?
Well, they focused on the genes that actually code for smell receptors in these deep sea fish. And what they found really challenges some of our assumptions about how this whole sense evolution thing works in the deep.
Oh, I'm intrigued. Lay it on me.
So you'd think darker environment probably means a super powered sense of smell, right? More olfactory genes, more of everything.
Yeah, that's kind of what I'd picture.
But that's not always the case. Turns out some of these fish actually have fewer of those genes compared to their shallow water relatives.
Now, that is surprising. You'd think they'd need to smell more, not less, down in the dark.
And that's the big question, isn't it? Like, what's going on here? It's telling us that the story of how senses evolved in the deep is way more complicated than just more equals better.
So what is the explanation then? If it's not just about having a ton of olfactory genes, how else are they smelling so effectively?
It might be about having the right olfactory genes, right? The type of receptors they have, how fine-tuned those receptors are to certain smells. Those could be huge factors.
Ah, so it's not just quantity, but quality too. Fascinating.
And then there's also the physical structure of their olfactory organs, their noses, so to speak.
Okay, I'm starting to see how this is way more complex than I initially imagined.
And get this, Kamala found a bunch of species that actually seem to be what you might call olfactory specialists, basically. Fish that have really honed in on their sense of smell to make it in this crazy environment.
Olfactory specialists. Okay, now I need names. Which fish are we talking about here?
All right, jot these down. Histiobranchus bathybius, Cynophobranchus caupi, Coryphaenoides armatus, Catatix laticeps, and Barythrites iris.
Okay, those are some serious tongue twisters.
Yeah.
But I'm with you. So what is it about these fish that makes them the master sniffers of the deep?
Well, one thing is their olfactory bulbs, the part of the brain that deals with smell. They're unusually large, especially when you compare them to the part that handles vision.
Ah, so they're really prioritizing smell oversight. Makes sense when you think about it.
Right. And a lot of these specialists are bottom feeders, so they're searching for scraps in near total darkness.
So smell is everything for them. But is there anything beyond just like the anatomy of it all? What else points to these fish being olfactory specialists?
Well, one of the species Kamala looked at, Coryphaenoides armatus, has this incredible adaptation. It actually has more nerve fibers carrying smell information to the brain than it has for sight.
Wow, they really went all in on the sense of smell. It's like their nose is working overtime to make up for the lack of visual information.
Exactly. And it's not just bony fur like that one either. Turns out even deep sea sharks, those apex predators, are relying heavily on their sense of smell down there.
Wait, sharks too? I always picture them as being all about teeth and speed. I need details on these sharks and their noses.
Well, get this. Some deep sea shark species have a 50.1 ratio of olfactory input to optic input. 50 to 1.
Seriously, so they're processing way more information about smells than anything they're seeing. That's wild.
It really emphasizes how important smell is down there, but at the same time, it's not like these fish have just given up on every other sense entirely.
Right. They have other adaptations too. It's not like they just ditched everything else once they mastered smelling in the dark.
Yeah.
So we've established that deep sea fish are basically like the master perfumers of the ocean, using their incredible sense of smell to navigate this like underwater world of scent.
Yeah.
But you hinted at some other adaptations too. What else are we talking about here? What other senses are we talking about?
Well, think about touch, for instance.
Oh, okay, touch.
Specifically, the lateral line system. It's something they share with their shallow water relatives, But in the deep sea, it's even more crucial.
Right, the lateral line, like a sixth sense almost.
Exactly. It's like having thousands of tiny sensors all over their body, letting them feel vibrations and pressure changes in the water.
That's how they see without seeing, in a way.
Yeah.
So what kind of information are they getting from that, would you say?
Oh, tons. It helps them navigate currents, avoid obstacles, sense prey, even feel predators approaching.
So it's all about these vibrations, these pressure waves, basically guiding their movements in the dark.
Yeah, exactly. And it's super important for schooling behavior, since they can't rely on visual cues as much down there.
That's amazing. So they're like constantly feeling the world around them, using these vibrations to make sense of their environment.
And you know what's even cooler? Scientists are now studying the lateral line system for inspiration in designing new technology.
Oh, really? Tell me more about that.
Yeah. There's this recent paper by Hu and some other researchers, and they actually described this super sensitive pressure sensor that they based on the lateral line system of, get this, deep sea fish.
Wow. So they're taking inspiration from these deep sea adaptations to create cutting-edge tech. What kind of applications are we talking about here? What could this be used for?
The possibilities are pretty mind-blowing. Like, imagine better underwater navigation for autonomous vehicles.
Okay, yeah.
Or super sensitive sonar devices to map the ocean floor.
That's incredible.
Even potentially new ways to do medical imaging.
Wow. So we're talking about like revolutionizing our technology by learning from these deep sea fish. Okay, that is seriously cool.
Hmm.
But we haven't even touched on something pretty important for, well, for any species to survive. Finding a mate. How are they managing that in the vast darkness of the deep sea?
Right. If you thought finding a snack down there was tough, try finding a date in the pitch black.
I can only imagine. It's a whole other level of difficulty. So how do they do it?
Well, once again, it comes back to their sense of smell.
Okay, so scent is playing Cupid in the deep sea too. Tell me everything.
There's this thing called sexual dimorphism, basically, differences in appearance between males and females. And it turns out it even shows up in the olfactory organs of these fish.
Really? How so?
Well, in lots of deep sea fish, males have these way bigger olfactory organs than the females. Like take the cyclothone species, for example. The males have these really prominent lamellae, those folds or plates in the olfactory organs, and they're much smaller in the females.
It's like they evolved these super sniffers specifically for finding a mate. So cool.
Yeah, it's wild.
But hold on, earlier we were talking about how some deep sea fish have fewer olfactory genes. So how does that play into all of this?
Good point. It's not always about the number of genes you have, right? It's about how you use them. Even with a smaller set of olfactory genes, you can still have a really specialized sense of smell if it's fine-tuned to the scents that matter most for your survival. And finding a mate, that's definitely high on the priority list.
Makes sense. So are there any extreme cases of this olfactory specialization when it comes to mating, especially in those crazy deep parts of the ocean?
Oh, absolutely. In fact, one of the most fascinating examples is the Mariana snailfish.
Oh, wow. The one that holds the record for the deepest living fish ever discovered.
That's the one, living at depths of over 8,000 meters where the pressure is unbelievable. And get this, even though it has a relatively small number of olfactory genes overall, it seems like those genes are working overtime to give it a super specialized sense of smell.
Wow. So even at 8,000 meters down, where it seems like nothing could survive, smell is still king. It's amazing, isn't it?
It really is. It makes you realize how little we still know about these creatures and how their senses actually function in those extreme conditions.
It's true. We've covered a lot of ground today, but honestly, we're just scratching the surface of this whole sensory world down there.
It's a good reminder of just how much more there is to discover about the deep sea. It's like this whole other universe right here on our planet.
Exactly. And every new thing we learn just makes it even more fascinating.
Well, I could talk about this all day, but I know we need to take a quick break. When we come back, I want to dive into something that's been on my mind this whole time. All right, so we've talked about all these incredible adaptations that let deep sea fish thrive in a place with crazy pressure and basically no light. But before we wrap up this deep dive, I got to circle back to smell. You mentioned earlier that the deep sea is like this massive scentscape, with each species giving off its own unique chemical signal.
Yeah, and it's a concept that's really got researchers fired up lately.
I bet. I mean, it makes you wonder, Could there be more to this whole scent thing than just individual survival? What if it's actually shaping the entire ecosystem down there?
Now you're getting it.
Wow.
We often think about senses as being for, finding a meal or not becoming one, but those chemical signals, they could be way more important than we realize.
Like how? Give me some examples.
Well, think about species distribution, right? Or how communities form in the deep. Even the flow of energy through the food web what if scent plays a role in all of that.
Okay, yeah, it's like these scents are basically invisible architects shaping the whole deep sea environment.
Exactly. Imagine a deep sea coral reef, for example. They're teeming with life, right? But how do all those different species find their place in that craziness? It could be those chemical signals guiding them, at least in part.
So instead of those visual cues that, shallow water species rely on, deep sea creatures are using smell to navigate this underwater jungle. It's like an invisible map.
Precisely. And that map is always changing too. Environmental conditions shift, and suddenly you've got this dynamic, ever-shifting scentscape that's influencing everything.
Wow. It really paints a picture of the deep sea as this incredibly active and responsive environment, even without sunlight. It makes you think, what kind of information are they actually communicating through all these different scents? I mean, we've talked about pheromones for attracting mates, but what else is being said out there?
Honestly, that's the million-dollar question. We're just scratching the surface when it comes to chemical communication in the deep sea. But think about it. Warnings about predators, maybe distress signals, cues about food, even signs of, environmental changes. It could be anything.
It's like this whole other language down there.
Yeah.
And we're just starting to figure out the basics.
Exactly. Every time we get a new tool, a new way of looking at the deep sea, it's like we uncover another layer of complexity. It's amazing.
It really is. It just makes you realize how much more there is to learn about these creatures and how much we can learn from them, too. I mean, talk about thriving in a challenging environment.
Absolutely. The deep sea is this incredible example of how creative evolution can be. It's a reminder that even in the most extreme places on Earth, life finds a way.
Not just survives, but thrives. Building these communities, these communication networks, it's incredible.
And it shows us how important it is to protect these ecosystems.
Yeah, the deep sea seems so far away, but it's connected to everything, the climate, biodiversity, even the future of humanity. It matters.
It really does. The more we learn, the more we understand how interconnected everything is. Well, this has been absolutely fascinating. Thank you so much for taking us on this journey into the sensory world of deep sea fish. I feel like my mind is officially blown.
The pleasure was all mine. And to everyone listening, never stop asking questions, never stop exploring, and never stop being amazed by the deep sea. I love that. And on that note, we'll wrap up this deep dive. Until next time, everyone, keep those brains engaged and stay curious.